We shall discuss the topic polynomial. Definition of polynomial. The polynomial is the algebraic expression consisting of variables and coefficients that involves the operations like addition, subtraction, multiplication and non-negative integers. Now what is the non-negative integer here? We have to see the exponent of each individual term in the algebraic expression. The exponent should be a non-negative integer like 0, 1, 2, 3, 4, etc. It cannot be negative or it cannot be a fraction. Okay? Otherwise, it will not be a polynomial. Different types of polynomial. If the polynomial consists of one term, then it is called monomial. If the polynomial consists of two terms, then it is called binomial. If the polynomial consists of three terms, then we say that it is a trinomial. But if the polynomial consists of many terms, including one term, two terms, three terms, all will be called as polynomial. Next, degree of a polynomial. Degree of a polynomial is the highest exponent of the variable involved in the polynomial. There may be many terms in the polynomial. Each individual term will contain certain exponents. For example, in this case, in order 3, 2 are the exponents of each individual term of the polynomial. But as 3 is the highest exponent in the polynomial, so 3 is the degree of the polynomial. Similarly, in this case, 2 is the degree of the polynomial. Next, how we write a polynomial. If the variable of the polynomial is x, then we write px, qx, rx, like that. If the polynomial consists of the variable y, then we write py, qy, etc. Now, values of a polynomial for different values of the variable. For example, let us take the polynomial px as x square plus 5x plus 6. Now, we can find different values of the polynomial px by assigning different values of x. Let us check it. So the values that we get for px when we have different values of x, these will be called as the value of the polynomial. Next, 0 of a polynomial. In the above example, we have seen that for some values of x, the value of the polynomial gets 0. Here in the example, px equal to x square plus 5x plus 6. For x equal to minus 2 and minus 3, the value of px becomes 0. So these minus 2 and minus 3 are the zeros of the polynomial. In this example, px equal to x plus 2, when we put x equal to minus 2, then px becomes 0. So minus 2 is the 0 of the polynomial. Again, when px equal to x, then for x equal to 0, px equal to 0. So 0 is the 0 of the polynomial in this case. Thus we have seen the word 0 does not stand 0. It may be any number, because as by definition, for the values of x, the value of px becomes 0. Those values of x will be called as the zeros of the polynomial. Next, the geometrical meaning of the zeros of a polynomial. One thing we remember, that all the polynomials or all the algebraic expressions represents a line or a curve. A straight line may or may not intersect the x-axis. Even the curve may or may not intersect the x-axis. Now, the number of points the curve or the line intersects x-axis will be the number of zeros of the polynomial. A straight line can at most have one intersecting point. That means it can intersect x-axis at the most at one point. For a linear polynomial, I use the term linear polynomial, means the degree of the polynomial is 1. That type of polynomial is called linear polynomial. And this type of polynomial, for example x plus 2, is a straight line. It will intersect x-axis at only one point. So there are only 1 zeros for a linear polynomial. If the polynomial is quadratic or cubic or any other powers or exponent, that will represent a curve, and a curve may intersect the x-axis at more than one point. If the curve intersects x-axis at 2 different points, then there will be 2 zeros. If the curve intersects the x-axis at 3 different points, then there will be 3 zeros. If the curve intersects the x-axis at 4 different points, then there will be 4 zeros. Okay, like that. So that is the geometrical meaning of zeros of a polynomial, that the number of intersecting point with the x-axis by the curve is the number of zeros of the polynomial. One more thing you have to remember at the same time, that a line or a curve may not intersect x-axis like this. If the line or the curve does not intersect x-axis at all, then we will say that there are no zeros for this polynomial. Okay, no intersecting x-axis means no zeros. Okay.